973, k closest points to origin. We have a list of points on the plane. Find the k closest point to the origin. Here, the distance between 2 points on a plane is the Euclidean distance. You may return the answer in any order. What? Oh, the answer is guaranteed to be unique, except for the order that it is in. Uh, hmm? Oh, yeah, except for okay. Um, okay. So they're giving 10,000 points. You just return. I mean, I think this is seems like a straightforward application of a heap. Uh, and a heap would do this in so actually, so there are two type of heaps that you can do on this. One is the trivial heap where you put everything and then you pop off k times. That's kind of n log n. And then the other one that you can do, which is a little bit fancier, it's kind of have a k heap, which means you make sure that the heap is on the k times. But yeah, the Python heap is it's a little bit it's a little bit fancy, but well, like a little bit weird. They're not weird. It's just because it's not in the standard library. But um, but yeah, I think one other. So I think that's straightforward, and you could do this in n log k time, which is probably optimal. I was going to think about maybe another algorithm, but given that it's probably going to be hard to do in more less than n log k. I mean, maybe you could do some like quick selection type thing. Uh, to kind of maybe get it to some probabilistic linear-ish time, but that's like ridiculous in complexity. I mean, nah, not ridiculous, just like a ridiculous. I don't know, it is more complex, I guess, is what I'm trying to say. I mean, it's not impossible, and it's not hard, but maybe I gotta do that and not be lazy. But cool. And the only other thing that I would mention for problems like this is that when you and it's something that I do, and a hint in general. And you may need to explain this if you're doing an interview. But whenever you see Euclidean distance, well, I guess they actually should describe what that means. Like, I mean, I know what it means, but like, I feel like they, just in case. But that means x squared plus y squared, I don't know, some distance square, right? Oh, I guess technically it's dx, something like that. Oh, that's terrible for me, but okay, something like that. Um, but the keynote here is that unless you need to, and even if you do need to like print the results or anything, square roots are a little bit messy that in two ways. One is that in general it's not cheap, so sometimes it comes into play. But the other thing is that when you're doing sorting and stuff like that. Sometimes floats you kind of get worried. So what I usually do is I leave them in the squared form and then only take the square root at the last possible second. So that's gonna be something that I'm gonna take advantage of. But I'm gonna just start with a heap. What's it? Heap Q? Is it heap PQ or heap Q? Oh, I guess it's just this. But and then now for points. Oh, oops. For I guess x, y in points. Uh, what am I doing? Oh, from the origin. Okay, so I was trying to find from where, but um, I think okay. So that is it. So one thing that it's a little bit unfortunate. I mean, I don't know. I wouldn't say unfortunate, but just like a little something that I have to remind myself is that between Python and other languages, uh, heap is actually sorted in a different order, which is always a little bit like annoying. And I mean, it's fine, and if you're used to it, it's okay. But the heap in Python is a min heap, where the heap in most other languages, I don't, at least all the other ones I use are all max heaps, and that kind of gets you into trouble sometimes, just because like if you assume one way or the other, and it's something that uh, I kind of ate it a few times because of silliness like that. But yeah, so that's something to kind of remind myself on. So we want to push. Okay, so let's just push a tuple, right? Where we sort by the distance, and then let's just x and y. Why not? Um, yeah. And we actually want this to be a max queue, because we want to get the k minimal element, so we always want to pop off the max element that's inside the heap. So yeah, so that's why I do a little bit negative, which is a little bit of a hack, to get around to get the max of a number, because it's the negative, is the inverse, and so forth. But yeah, so now we push down the heap, and then now I guess the peak is also a little weird. It's if I guess it's, yeah, I guess we just heap pop. And then now since we don't care about the order, we don't even have to actually do the k pops. So I guess maybe it's probably in clean way. But we just return the results, which is for I guess x, y for dxy in heap, something like that. Okay. Wow, I said a lot of things for what turned out to be like 5 lines of code. But sometimes, that's what algorithms get you. Like like especially when it gets to like dynamic programming and stuff like this, you look at other people's code and it's like, well, it's 5 lines of code. I have no idea how it works, and there's no way I could come up with this. For heap, it's a slightly, because I'm using standard library, to be clear. So in this case, just library in general. But yeah, cool. I use more memory. Can you do with less memory? I guess I could. I didn't need to keep on duplicating lists, but it's fine. I don't really worry about it. But yeah, I mean, I think this is actually, maybe not the k closest point to the origin part, but I would say on a 1D plane, which is just a list of numbers, this is probably one of the standard usage of heap. And I think for this problem, especially on an interview, I haven't gotten. I was not asked this per se on an interview, but it definitely actually, my last job, the interview that I was on where I was for a number of years, the interviewer asked a problem which I needed to know the heap. Well, I just need to know heap rather, as part of that problem, because it was like a 3-part problem. It's a very fancy graph problem with heaps and stuff like this. So it does make a difference whether you want min heap or max heap and stuff like this. And he was very thorough about it, and he drilled me about it a low number of times. So anyway, so from my personal experience, definitely heaps are important. People will ask you about it in general, and yeah, so I definitely recommend kind of practicing this problem, and also making sure why you want min heap sometimes and why you want max heap. And obviously some of it depends on the problem, because some problem just be like, oh yeah, we want the minimum order. But even then you have to figure out why and the differences and be able to explain it, right? Because that's important to the interview. I mean, they just try to figure out, why you answered the way you did. But yeah, but otherwise, it's a standard problem, so I definitely recommend it. Get used to it, get practice. Heaps of important is part of, it's not quite part of sorting, though heap sort, I know, but definitely like the usage of heap is pretty common and pretty fundamental in terms of like what people ask on an interview. So I definitely recommend practicing this one. And this is, a little probably like on the easy side of heap, as long as you recognize heap. But as soon as you recognize heap, you still have to kind of go through the extra steps to kind of go through it. But yeah,